Hello, science students. Welcome to our final video about the scientific method. Today, we're going to learn about another emphasis area this year called a four-part conclusion. Remember that the scientific method is a process that plans out an experiment to help try to show a cause and effect relationship between two variables. They start with a question, identify those variables that are involved, they predict what they expect to happen in the hypothesis, conduct and carry out tests, observations, and collect their data, and then they try to analyze it and find patterns. This final step is where we communicate what we've learned to the reader. That good conclusion is going to explain exactly what you've learned and understood from this experiment. And since science literature is read and shared among our peers in the process of peer review, your information and your understanding gets shared with the entire world. You need to make sure to cover four important topics in a good conclusion. You need to answer the question, evaluate the hypothesis, assess the reliability, and try to modify or improve the experiment. That first part, answering the question, goes back to that whole thought or idea or question that started it all. That's the very, very first thing we did in our experiment, was state our question we're trying to understand. Your answers need to make sure that you provide evidence to support what you're saying. If you don't go back and quote your measurements and data, there's no point in doing the experiment. It's the support for what you learn. Let's take a look at this data table based off of an experiment trying to understand how does the temperature of water affect the growth of a plant. They took the same type of a plant, put it in the same type of soil, same amount of soil, same size of pot. The only thing that they changed was they watered some of the plants with 40-degree water, some of the plants with 60-degree water, and some of the plants with 80-degree water. They did multiple trials with each water temperature and recorded their results. Based on this information they collected, we can answer that question, how does the temperature of water affect the growth of a plant? See what you come up with. How would you answer this question? If you said something like, the temperature made the plants grow differently, technically you answered the question, yes. But it's a very, very weak answer. It simply states that the temperature made the plants change. That's true. But we need to improve that answer, especially if you're trying to get a score better than a 2 or 3 out of 5 on this. That's very, very weak in this section. A better answer that would reach that good range has to identify that trend. Using hotter water makes a plant grow taller. This not only says that it's changing it, but it identifies how. It says that the hotter the water, the better the plants are going to grow. So it finds that relationship and identifies it. A great answer, though, includes both of those weak and good answers and adds in data. So it states that the temperature changes the height the plant grows. It says it. Then it goes on to explain how it does that by identifying that when the water's hotter, the plants grow taller. So it identifies the relationship. And then finally, it includes data from the data table to support that idea of hotter was taller. They actually include the numbers that show this relationship. After you answer the question, it's time to take a look at the hypothesis. A hypothesis can be supported by the data, or it can be rejected by the data. We never say the hypothesis is right, correct, or wrong. The data could support the hypothesis, and a later version or a modification or another attempt as we learn more in science may then reject that hypothesis and it is no longer considered to be true. So we say a hypothesis is supported or rejected. When the data agrees with it, it's supported. When the data shows a different pattern than we predicted, it's rejected. Great answers will include that data to show and illustrate why it was supported or rejected. In that same example here, we have the question, how does the temperature of water affect the growth of a plant? The hypothesis for this experiment was if the water is colder, then the plants will grow taller because they will not get burned. Take a look at the data and the patterns. Did this hypothesis get supported by the data or did it get rejected by the data? This hypothesis was rejected. The data disagreed it. The colder water did not grow taller. It was the shortest. And so you'd go on, a good answer would explain that the hypothesis was rejected because it predicted colder, but it was actually warmer that grew taller. To really step that answer up to a great answer, you need to include quotes from the data. It includes that idea that the hypothesis was rejected because colder was not taller and warmer was taller. It goes on to quote the data and said that the cold water had the lowest measurement, 67 or 65 and a half, and the hot water had the tallest. And again, they went back to their data table, to the measurements they gathered, and used them to support what they were saying. The third part of a four-part conclusion assesses the reliability of the results. It's one of the most important sections because it explains whether these answers and whether the hypothesis and whether the conclusion really actually holds much weight or not, or if there are some major flaws that need to be fixed and addressed, and hopefully we'll still get the same results. Some things that could be talked about in assessing the reliability of your results would be talking about any outliers in your data. Were there any measurements that were so far off you feel that they needed to be removed? How did those affect the outcomes? Did that change the trends or the results? What difference did those make in the possible patterns you found? Or you could talk about other variables that you did not expect, but you think may have affected the results. Again, let's take a look at this example of temperature and plant growth. As you look at the data that they have in that data table, do you see any value that is way outside of the normal? I'd say no. Looking at it, all of the values have a range of 4 or 5 centimeters difference in the results, which seems pretty comparable at all water levels. Granted, you're getting higher heights at the hotter water, but every trial was around those same values. So no, I would not say there's any outliers in that example. But would you consider these results reliable? Is this enough information to convince you of that pattern that hotter water is going to make plants grow taller? I would probably say no, looking at the information that I can see here. Why do you think it might be not reliable? Some things to think about are that there were only 3 trials or tests for each value. In a really good experiment, we'd want to have a lot more pieces of data. If you think back to our data analysis, remember, more tests are better. 3 trials is a very small data set. It could be expanded to include more trials. And then we also need to think about is there a water temperature that is too hot for the plants to grow? Could there be a top value where plants no longer start increasing their height Maybe they do start to get burned at a certain point and they become damaged. After identifying those things that could affect your results, you want to talk about the final part, how you plan to modify or improve this experiment. There's two big ideas that could be covered in this last section. One is if there was anything that you said affected the reliability of your results, you need to explain how you're going to fix that. If you said that there were not enough trials, how will you fix it? What will you do instead? The other thing you could include is, what do these results make you think about or ask next? What's that next step in this example or this progression of understanding? What's the next thing you're going to investigate to better understand these relationships? Let's take a look at that example again of temperature and plant growth. A good answer on this would say something like, the reliability of the results could be improved by using a range of water temperatures from 40 to 180 degrees. It's talking about how it plans to fix or address that idea of not using enough water temperatures to see if there's a temperature that's too hot. Or another good answer could be talking about something like, the results raise the new question, how does the water temperature affect the production of fruit on a strawberry plant? So you'd get more specific, not just about water temperature, but now what does that water temperature do to something other than height? How does it change the size or the amount of fruit on a particular plant? Those two ideas are kind of related, and the information you learn from temperature and plant height could also apply to temperature and plant fruit. A really great answer, though, will go deeper and include both of those ideas. It includes the idea that the reliability needs to be improved by expanding the range of temperatures. It also goes on to explain why it needed to be done. Temperature could be too hot. We want to try to see if there's a temperature that's too hot. So not only does it say we need to expand it, it then goes on and tries to provide some more support about why it needs expanded to explain what that expansion would help to better understand. And then it also includes items about what types of questions could be raised next and where the next experiment might go as someone tries to fully understand the relationship or the patterns between temperature and plants. Thank you for your time. I hope you have a wonderful day.